So this might be a little bit challenging since you just learned this today. We are solving, well, KP, I said this in the class, but it's something that you can write for now because we will very quickly just like we'll start to use that number. But just so now, a review on today's class is lecture 10. Okay, so K equals to, yeah, it can be equal, can be P based on what we have, but it's always the reactants over the product, right? So, and keep in mind that's concentration. So we will have B, and since there are only one, so it's B, that's one. I don't have to write that one, but I just like to write it, so it's clear. And then A is 1. Are we cool with that? Okay, so which you are going to see in this case, where's my, I think it's 2022. It did not actually tell us, oh, what's the concentration because it's our gas. Basically, we just change all the K into P. Well, it's the same expression, right? It's kind of like the concentration will change to, since it's P, so Kp, we'll change that into Pb. It's the same thing, but it's that's how I, 1, okay, Pa1. Did I miss any coefficient or am I good? Okay. All right. So, and then there is something that I'm about to teach on Thursday, but it's the limiting reagent way of how we solve this type of question, which, where's my graph? Yes, okay. Is that start with, start means initial, right? Right? If you still remember in limiting reagent, we did something, okay, we'll put initial here. And it start with 1 atmosphere, so 1.0, and then everything else is 0, right? Okay. And then in limiting reagents part, I also have a table of how much you use, right? And then that uses C for how much you change. Okay. In part of the decision that I will teach on Thursday, we'll show you, let me see. We'll show you the video on one of the lecture notes that I'm about to teach you. But I'll just show you for now, so you know what's finally they will look. It's something like a table, okay? Something like a table like this. Something like a table. Finally, okay. I'll show you the video. It's like our limiting reagent. But this is what we're doing. Okay, I'll show you the video as well. So finally, we'll get to a table, very like our limiting reagent, but what I'm doing here is because I will, like this is direction for sure will move to that direction, right? So I will consume some of my A, right? Because I don't have any B and C. Once I throw A in the container, there's only one way that this reaction will go, which is make more B and C. And based on the coefficient, because it's 1 here, 1 here, 1 here. So whenever I consume X more of A, I will form X more of the B and X more of the C. Make sense? All right. And then E for equilibrium. Okay. When I reach equilibrium, I will have 1 minus X. And here will be 0 add X, and 0 add X. Stuff makes sense so far? Okay. And if we are going to plug in our equilibrium expression, which, back to the K, okay, Kp equals to, okay. I'll just use the bracket because I think you know what it is. It's just, I just don't want to write so many letters. I think that you know what I'm talking about. Okay, now we'll plug in when it is equilibrium. Okay, so equals to, okay, B is at X, right? Okay, B, okay, I'll just write X. C is also x, right? And A is 1 minus x. Make sense? Okay, that's where the math came. So you need to solve for x. Which means, okay, that's on your scratch paper. Okay, scratch paper. That will be x squared over 1 minus x equals to 1, right? 1 equals to x. Okay, so x squared equals to, okay, 1 minus x. We just move 1 minus x to the other side. X squared add x minus 1 equals to 0. Okay, solve for x. Use your high school, whatever. You good? Yeah. Okay. Okay, once we have the x, I'll just show the x on the board. Yeah. That's on your scratch paper, okay? If you really just did not, I think if you're up to here, will give a lot of partial points if in the exam. Yeah. Or I think your calculator should do that for you, right? I think so.
Oh, so it's like a multiple choice option.
So, okay, in case I'm also showing to the video, if you need help, this one is the one you should use. Okay, so this one.
Oh, the quadratic formula.
Yeah.
Oh, I see.
See, did you see?
Because we're factoring. Okay, I see.
Oh, you good? Yeah. Okay. That's why I said today you need this. Yeah. And the x is only, we solve x, but we are not, because we're also solving, okay, what's asked? Let me see, what's the question asked? Ask for the pressure of B. Oh, okay. So the first, okay, question A, ask for pressure of B. Okay, then that's straightforward, which is x equals to 0.618 atmosphere. What's the question asked for?
Find the partial pressure of B.
Okay, that's A. We solved that. Yeah. 3 point. Okay, that's it.
What is the total pressure in atmospheres?
Oh, then that's, okay, for part B, total pressure. Okay, total pressure, which means you need to add all of them, right? So as equilibrium is PA add PB. Okay, that's Dalton's law. That's what we learned today. PC equals to 1 minus x add x equals to 1 add x. Okay, and then that would be 1.618 ATM. Yeah. Are we good? That's Dalton's law today. Good?